3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at Webb's progress. A few months ago the James Webb Space Telescope was launched in a folded position, in order to fit within the fairings of the Ariane V. After hundreds of different vital deployments, and a nearly 1 million mile journey, Webb has been successful in every aspect. Now the JWST works to finish alignment, and prepare to take some of its first high-quality images. Just yesterday NASA released another update regarding Webb, and what the next generation space telescope has been up to. Specifically, they highlighted Webb's general progress along with it reaching an important alignment milestone. This milestone consists of passing the fine staging phase, where every optical parameter that has been checked and tested is performing at, or above, expectations. This multi-billion-dollar telescope is meant to discover and unlock unique aspects of the universe along with looking farther into the past than ever before. This most recent update provides crucial and promising information for the future of the James Webb Space Telescope and its current operations. Here I will go more in depth into the details of this mirror alignment milestone, and what the future of Webb will look like. On March 11th, the Webb team completed the stage of alignment known as fine phasing. At this specific stage in the commissioning of Webb's optical telescope element, every optical parameter that has been checked and tested is performing at, or above, expectations. NASA also points out that the team found no critical issues, and no measurable contamination or blockages to Webb's optical path. The observatory is able to successfully gather light from distant objects, and deliver it to its instruments without issue. This is a huge deal as it means some of the most important aspects of Webb are working even better than expected. While this is great news, there are months to go before Webb ultimately delivers its new view of the cosmos. However, achieving this milestone means NASA is confident that Webb's first-of-its-kind optical system is working as well as possible. More than 20 years ago, the Webb team set out to build the most powerful telescope that anyone has ever put in space, and came up with an audacious optical design to meet demanding science goals, said Thomas Serbichin, Associate Administrator for NASA's Science Mission Directorate in Washington. Today we can say that design is going to deliver. In addition to some of the main points within the update provided by NASA, the agency also released a very special image Webb captured. This image is labeled as the Telescope Alignment Evaluation Image. It turns out that the purpose of this image was to focus on the bright star at the center for alignment evaluation. However, Webb's optics and NIRCam are so sensitive that the galaxies and stars seen in the background show up. At this stage of Webb's mirror alignment, known as fine phasing, each of the primary mirror segments have been adjusted to produce one unified image of the same star using only the NIRCam instrument. This image of the star uses a red filter to optimize visual contrast. In addition to enabling the incredible science that Webb will achieve, the teams that designed, built, tested, launched, and now operate this observatory have pioneered a new way to build space telescopes, said Lee Feinberg, Webb Optical Telescope Element Manager at NASA's Goddard Space Flight Center in Greenbelt, Maryland. While some of the largest ground-based telescopes on Earth use segmented primary mirrors, Webb is the first telescope in space to use such a design. The 21-foot, 4-inch primary mirror, much too big to fit inside a rocket fairing, is made up of 18 hexagonal, beryllium mirror segments. It had to be folded up for launch, and then unfolded in space before each mirror was adjusted, to within nanometers, to form a single mirror surface. Now that we know the most recent phase Webb has completed, we can look at the telescope's next step. Specifically, with the fine phasing stage of the telescope's alignment complete, the team has now fully aligned Webb's primary imager, the near-infrared camera, to the observatory's mirrors. We have fully aligned and focused the telescope on a star, and the performance is beating specifications. We are excited about what this means for science, said Rivakesky Kuha, Deputy Optical Telescope Element Manager for Webb at NASA Goddard. We now know we have built the right telescope. Over the next 6 weeks, NASA will continue through the remaining alignment steps before final science instrument preparations. The team will further align the telescope to include the near-infrared spectrograph, mid-infrared instrument, and near-infrared imager and slitless spectrograph. In this phase of the process, an algorithm will evaluate the performance of each instrument, and then calculate the final corrections needed to achieve a well-aligned telescope across all science instruments. Following this, Webb's final alignment step will begin, and the team will adjust any small, residual positioning errors in the mirror segments. These are extremely complex and unbelievably minuscule changes that make a big difference for the images Webb produces. The agency is on track to conclude all aspects of optical telescope element alignment by early May, if not sooner, before moving on to approximately 2 months of science instrument preparations. Webb's first full-resolution imagery and science data is expected to be released in the summer. Webb is the world's premier space science observatory and once fully operational, will help solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe the mysterious structures and origins of our universe and our place in it. The JWST and NASA had one more fascinating image to show the telescope's progress. Not long ago the agency provided a selfie of Webb, where you could see one out of the 18 mirror segments lit up. This was the case as the mirrors were not aligned at the time of the image being taken. Very recently, however, NASA released a new selfie of Webb. This new selfie was created using a specialized pupil imaging lens inside of the NIRCam instrument that was designed to take images of the primary mirror segments instead of images of the sky. This configuration is not used during scientific operations and is used strictly for engineering and alignment purposes. In this image, all of Webb's 18 primary mirror segments are shown collecting light from the same star in unison. This one image alone shows an impressive amount of progress in a very short period of time. This progress is expected to continue over the next few months before some of Webb's very first high-quality images are taken. Conclusion. Months ago, the James Webb Space Telescope was launched into space and sent on a trajectory for L2. During this long journey, the telescope successfully completed hundreds of deployments, all of which necessary for the future of Webb. Now in the middle of March, the JWST has not only arrived at L2 and deployed, but is finishing the alignment process for all 18 of its spirator mirror segments. Based on information from NASA and images provided by the agency, this process seems to be going extremely well. We will have to wait and see how the telescope progresses and the impact it has on the space industry. Thank you very much for watching.